All right, so I wanted to spend a little bit of time today talking about your designs, your reliquaries, um, as it relates to actually 3D printing these. Because the intent here is, yes, we're making intentionally more ornate designs, but we want to actually 3D print them. And the trick is we want them to 3D print as functional objects, both as there will be some kind of a moving component to this, but also your printed version has to interlock with the provided actual bit of acrylic tube. And one of the main things that comes into play is clearances. We talked a little bit about it before, but the difference between, like, say, modeling something and then machining it with like actual cutting tools and things from like machining something with like a, with a lathe, a mill, whatever, some sort of actual like say metal machining, you can actually keep extremely high tolerances. You can also kind of let it slack, but you can keep very high tolerances. When it comes to 3D printing, yes, you can also do that too, but there's things to be aware of and compensate for. The main thing is when you're 3D printing with a filament printer, as we're going to be printing the bulk of these, it takes your model and what's called extruding it. It extrudes it because the actual printing head, it basically is like a hot glue gun that's on a computer controlled arm. So what happens when you use hot glue and you try to run it down on a piece of paper or something like that? It's not like it stays exactly put. It kind of squishes down. And that's exactly what happens with 3D printing. So you cannot keep a like zero point zero 0.05 tolerance or 0.05 millimeter tolerance with a 3D printer, at least a filament printer. I say this because there are others, of course, the resin printers can be much higher toleranced. Um, but you have to compensate for some things. And essentially, all you have to do is just open up your container a little bit, usually in the range of about at least zero point 0.1 or 0.15 millimeters spacing. And that's just to help give a little bit more. Now, at most, depending on the fidelity of your printer, like zero point 0.5 is a lot to give extra spacing, but it's not unheard of. The ones we're using are pretty well dialed in, but what I mean by that is, all right, so something like this. Okay, we have our acrylic tube designed, and we took proper dimensions for this, and we know, yep, that is exactly the size of the acrylic tube. That is already made. That is something we can count on. But how does that work in here? Now, with this model, what we went and did is, I'll just hide one of the parts here, is we modeled these rings and things directly off of this cylinder. So that means it would be an exact fit. Great, except we have to account for that little bit of squish that occurs. So what that means is I need to essentially just widen like this area a smidge. So to double check, what is the diameter of our tube here? Is right on 50 millimeters. Okay. Now, again, we were getting some pretty exacting, but you never know. Sometimes upwards of even half a millimeter size difference because the acrylic tubing is not designed for like machine tolerances. It's designed for like plug and play tubing. The tubes we're using are actually built for like dust collection things. So it will plug into like PVC pipes and things like that. So it's not meant to be ultra high tolerance because the glues that you are used, things like that, take up some space and then they kind of fuse the materials together. Yada, yada, yada. Material science. Don't really need to get into that. But okay, well, I built this design directly off of this tube. How would I compensate for that? Well, there's a few different ways. One, if you're building something, yeah, you can just intentionally build something a little bit larger, add in that little bit. But with something like this, okay, I need to actually have a teeny bit of a gap between the wall of this acrylic tube and the wall of this model. And right now I've modeled them as exacting. Okay, well, that's actually pretty easy to fix. All we have to do is something that on this one is, all right, well, if I already used an extrude to cut this whole thing away, why not just do exactly that? So what we can do, I don't know, from here, a simple, just an additional cylinder. maybe here. Actually, probably would have worked better up top, so let me cancel that. Additional cylinder. We'll use this top edge of the tube as a plane. As you mouse over to the center, we get the concentric circle symbol. Let me see if I can change color. Nope, that doesn't help at all. My circle is blue, and a blue background does not help. So right there, and we can take this out to, well, it's at 50 is the already designated size. But wouldn't hurt to add in just a teeny bit more. So we could do something like make this cylinder, this circle, 50 point, let's just say 1.5. So it's a teeny bit larger. Okay, that can become our cutting tool. Probably should have just used this as a sketch, but here we are. While I'm going to do this, let's hide that tube component. And this would be me using this as a cutting tool. I can just, oh, somehow did I accidentally create this on there? Ah, there we are. Double forgetting where I actually built things. And of course, there's other elements that are somewhere. Anyhow, so I can drag this cylinder down. Now, unfortunately, I'm accidentally getting an additional part in here. Let me just hide some things. There we are. Much better. And all this is doing, you can see as I cut down, I'm just making a tiny slice more. So let me only take this about halfway, and I'll use the section analysis to let you see what I'm doing here. I hit OK. Turn my section analysis back on that I already have created. And I can't actually see what I'm doing. So let's go back and edit that. There we are. It creates a line, but there we are. Just trying to get this in alignment. Hit OK for that. And as I zoom in, you can see the difference. The original line down here and this slightly wider line cut has just this little tiny step. That's all I need to do. So take that extrusion or that cylinder all the way, oh, too many zoom out, all the way down. I was just doing the partial so you could see. So take this all the way down to the logical end or to the actual designed end. And now when I unhide my tube, oh, wrong one. Where's the one that I'm actually using? There we are. You can see that I have just a tiny gap, and that's okay. Having a little extra gap, compensates for any squish that occurs, any slight deviation in the plastic material that gets extruded from the 3D printer, and gives you a little bit more wriggle room. Ultimately, these are going to get glued together, so it's not like we have to keep absolute press fit tolerance. Press fit tolerance refers to something that does not need glue. It pushes together and it's made so tightly that the friction from the two different sides keeps it installed together. We don't need that. So I used 0.15 millimeter larger than the tube in this case. That's probably a good amount. 0.1 to 0.15, and I will type that out in the notes, is usually a good size extra to use if you need to install a 3D printed part against a prefabricated object you have already taken dimensions from. So that's a really effective way to add some dimension to it. So, all right, great. I have my part that's already cut. Let me turn off section analysis. So how do I now take this out for 3D printing? Well, something like this, you're probably not going to get we probably don't need to do anything more to it than what it already is. It's just this whole design here, as this whole body, it'll be taken out as one solid object. Cool, that's fine. Obviously, the actual tube does not need to be printed because that is a physical object already existing. So with this model, I'd use two of these. And since I have the two, and I've already adjusted this one, I could just take this one out and print it twice. I don't necessarily need to make the adjustment to both of them. It definitely makes sense. And in your case, for your models. Definitely do it to both models. But if you're making and printing this yourself, you would know that I don't use the top one, use the bottom one. That's the one that's adjusted. That's what I mean. But for your case, please, yes, do make the cut, make the adjustment to both sides so I know that they're both done. All right, great. That's one. What about a more complex one? My alien coffee pot. I can't not see a coffee pot on this. Well, one of the things we talked about was printing or modeling to print as separate objects. Now that reliquary with the two caps, yeah, that's you're printing the two caps. That makes sense. But this one, and because it does in fact have to have some kind of opening function, well, how would you create that? Well, one of the parts on this is the lid that opens is literally already a part, meaning that's flat on the bottom. Let me do a color shift mode so you can see it more clearly. That's just a flat object. Great. This top flat object. Great. But this also has all of these little funky bits to it. So sometimes printing an object that's this complex, you would need to break it up intentionally. So with this, and I talked a little bit about before, but something like I said, like with these pipes and things, do not connect those, do not join those. Leave those as separate bodies entirely. Because the benefit here is I modeled this just with like these openings, and just like with the cylinder before, this tube could just slip right in and be glued in place. No problem there. Now, there will be a minor issue in that I need to adjust this slightly because you can see it doesn't line up quite perfectly, and it's slightly too large for the hole. So that would be like, yeah, no harm in taking that pipe tool. Where does that occur down here? There we are. And edit feature. And all right, it's currently 5 millimeters wide. Maybe I should bump that down to like 4.8. It's a minor change, but it's going to leave me just a tiny bit more gap for installing right there. So leave yourself a tiny bit of wiggle room, 1 to 2 millimeters on something like that. Probably not a bad thing. It's not really going to make a big difference in the long run, but consider things like that. But that's all well and good. But what about the whole thing as a whole? Well, same deal here. This tube currently is exact fit for the shell around it, or vice versa. The shell around it is an exact fit for that tube. Exact. So I would probably need to go ahead and do the same thing as I just did, as in let's activate that component. Let's say create a cylinder on top of that tube. Capture. It's just asking me, do I want to leave the lid out there? Actually, I should probably undo that. Yep, let's revert the position and then I'll just hide that lid. That makes it easier. So creating a cylinder at the top of that open tube, just like it did before. What is the current size? That is a 44 millimeter. So let's say 44.15. Just a tiny bit larger. It's going to help. Might not even be a bad idea since this is more complicated or larger here, and it might not even be bad to bump that up even more to like 44.2. It's all going to get glued together, so it's okay. Taking this and all the way down will let me cut through just ever so slightly. Don't forget to hide your acrylic tube because you don't want it like cutting that away and deleting it. Cool, there we are. So to that effect, it cuts it ever so slightly more. So now when I unhide that tube and zoom in, and you can see I just have a little bit of a gap there. Good. That helps a lot. But what about this whole thing here? Because when it comes time to print, and I'm going to go ahead and let me save this. Widen tube. I know I didn't spell widen correctly. Leave me alone. Let's go ahead and 3D export to 3D print this. So I'm just exporting it. That's fine. 3MF, whatever. Go into downloads. Good. So I'm going to change over to the actual slicer program and show you what's going to happen with this. So where is my downloads? There we are. Drag and drop into there. All right. Seems a lot larger, but it's actually quite small. So look, just as it exactly is, and don't worry about this part. I'm just changing the fidelity of it. Let me go ahead and slice that. I'm getting an error or what's called an overhang perimeter because I cannot print in 0G. Gravity is a thing that exists. So I'm going to have to create supports to support this overhang and thing. So I can go ahead and let it create supports. Let's just say supports everywhere because I'll need it that way. If I slice. This turns the whole thing into an entirely different support thing. And look at the time. It takes 9.5 hours to print this thing. And that's all support. So one of the few things I could do is, all right, let's just say I can figure out a way to print this on its side, which actually makes a lot of sense. So let's take this object and I'll try printing it on its side, like out in front. All right, let's just see what happens that way. And I'll have to do supports everywhere also. Okay, that made it a lot worse. It's 10 hours now. But we can do things like, I don't know why this is being so very sensitive. We can do things like slicing this model apart. What I mean by that is, well, let me change to no supports and what it would take to print one. All right, so if I didn't have to have supports, 3.5 hours or almost 4 hours. Way better. Now that sounds like a really long time. It's not because you're using a huge amount of material. It's just that, yeah, it takes that long to put that amount of information down. Well, why wouldn't it make sense to put it on the backside here? Well, it might. So let's try that side overall. Try slicing it that way. All right, that actually printed about the same. Problem is now I'm going to have this weird stepped backing here. You can see how it steps up and up and up because as you can see all these lines, those lines aren't just there to show you just because it looks weird. That's the slicer taking your 3D model and slicing it into layers. So I'm going to have to compensate for that somehow. And one of the easiest ways is like literally chop your model in half. That can work pretty easily. So and the good thing is, well, you can actually do that in a printer, in a slicer program. Let me do this. And let's say I want to actually cut this thing. Well, sure, right in half, right where it's saying. We'll say slice that. Oops, I didn't mean to hit slice now. Yep, go ahead and cut it. Cool, perform cut. That literally chopped my model in half. The problem with doing this, and I can now move these around, and I'm still going to have to like just, make some supports, blah, blah, blah. But the problem with something like this is I'm going to have to figure out a way to glue these back together and them not get out of alignment. So when it comes time to some of your models, what you can do is if you know you're going to have to cut something in half to make it print better, or if it's in several pieces, make it to where it actually intentionally is broken apart and can be realigned with what's called registration keys. So let me go back over to Fusion, and I'll just give you a really simple example of what I'm talking about. I'll talk about that one in a few, maybe. So let's just say I have this, sure, a cylinder, whatever. Doesn't matter. Let's just make this like 50 millimeters wide and so tall. Cool. But I know I'm gonna need, and here, tell you what, just so you have just so you have something to align to, so you can kind of see what I'm doing here. Let me just throw like a little notch in it so you can see so I don't get out of alignment. Literally does not matter. I'm just making that to extrude that shape down. Let's do to object to the bottom. All right. I just made a little notch just so you can see just so you can get a little bit of a reference here. Okay. So say I know that I'm going to need to cut this in half. All right. Well, then let's do exactly that. We'll use a construction plane just because I don't feel like drawing a line. We'll go an amount up. It doesn't matter in this case. And we'll use that line to split the body. That's the body. Let's use that construction plane. Oops. As our cutting tool. Bam. So now I have two bodies, top and bottom. Well, I need to make sure that these will stay locked in place. Now there's different ways of doing this, and some people just choose to use different things. Doesn't really matter. Sometimes. So what a lot of people like to do is things like, all right, let's just on the top here, we could use like a sphere. We could just do one. And I don't know, let's make that 10. We'll do a join. And then for the top, we could do like a combined cut. So target body is the top, tool body is the bottom. Make sure we save our tools and do a cut. And I only did that so that way now we have the little bot that has a little sphere in the bottom on the bottom. And we open up the top. It's got this little key. It's called what's called a registration key. Now, when I put them back together and I glue them back together, they're not going to slide, but they could very easily, dang it, they could very easily rotate out of position because that's just a sphere. So what I have found, a much better solution, and let me just undo the little sphere there, is instead something like a square or triangle, whatever, some kind of a polygon. So I'm going to draw on here in the center, just because center makes it easier, because I can use a center point, and make something like, I don't know, whatever. Let's just say, sure, 8. Doesn't matter. 8 by 8. Make it a square. Great. It's literally all I have to do. A little square there. I'm going to extrude that square up, let's say 5 millimeters. And I'm going to put a taper on it, let's say 45, just because why not? And 5 millimeters is way too much for that. So maybe I need to make it less. I don't know, whatever. Little notch there, little square notch. Great. Now do exactly what I just did before. I'm just going to do a combined cut. Target body on the top. Tool body is the tools on the bottom. Make sure I save the tools. Bam. So same deal. Now I have a little square protrusion on the bottom and a little square notch on the top. So now when I go and glue those back together with super glue, as we'll use, now they're going to stay in the correct position and they cannot twist either. So sometimes not twisting is important with, like, say, if I had to cut this object apart, everything's pretty important that it doesn't twist and stays in alignment. But if it's something like the first model and I had to make sure that I wasn't losing parts, yeah, who cares? The whole thing rotates anyway because they're not necessarily aligned. Or something like this, if it is important to you that the patterns stay aligned, you can probably eyeball it pretty darn close and it won't be a big deal. But the one other thing is, like I was saying, you want to account for a little bit of squish. So what I often will do on my own models here is I'll use a press pull, which is again just um like a side or like an offset. That's exactly what it is. And I will go in on like these faces, probably all of them, just to make no harm in making the top a little bit larger too. And let's do what we just did. Let's make it like 0.15, sorry, negative, so it goes outward, just a tiny bit larger. So now when I'll do a section analysis so you can see what I'm doing here. When I look around, now you can see there's just a tiny bit of gap there, and that'll account for any squish. And you have a little bit of space on top. Yeah, helps you with alignment with like glue and things too. The 0.15, if you find that's too big, make it a little bit smaller. But those are some really simple ways of building something that needs to stay in alignment. Now, some of you have some models that have um, additional, like multiple components that need to come together. So I figured I would just do a quick reference on something like that too. So let me make like a quick square here. Actually, let's start with a sketch instead. I think that'll be faster. So I'll do a center point square. I don't know. Let's just say 100 by 100. Doesn't matter. And then some of you have like poles, and let's say that's 10. Great. And I'll do a circle pattern of that around the center point. I need 4 of them. Those all align directly. Great. Okay. So I'll do an extrude of the what will become a base and also a bottom, but let's just say -5 just because I'm going to go that way. Great. And then just to help, I will new component holes. So now when I go and extrude those poles, they will come off as separate objects entirely. And let's just say, I don't know. Oh, not 1,000. That's way too many. Let's just say 100 again. New bodies entirely. Great. Okay. So how do I keep this sort of thing in alignment? Actually, works really well. Pretty much the same thing. So, and let me just real quick also have a top. Might as well use that sketch. Ugh, should be getting those. No, I didn't want to make a sketch. Dang it. I will often mix up those sketches and extrudes. All right, the whole thing. Start not at the profile plane, but at the object. And then again, I don't know, like I did like 5 millimeters. That's fine. Nope. I don't want it on that one. I want it up there. Perfect. There we go. Okay. How do I assemble all of this and keep it all in alignment? Well, it makes perfect sense. These top and bottom are all flat. Yep, sure. Great. Makes sense. But how do I keep all this stuff from twisting and aligning? Well, some of this is just going to be like really careful. But honestly, easy thing here would be, all right, let's do what I just did here. As in, all right, let me hide the top and let's do an extrude on top of these. And let's say, I don't know, a 3, and I'll do a negative taper of, I don't know, -60. I am absolutely just picking numbers out of nowhere. I could say 45, cool, great. Join that. So now this is slightly taller, and it absolutely will go into the body of the top here. So, all right, let's do that. A combined cut. I need the target body there. Tool bodies are all the poles. Keep the tools. Great. So now when I hide the poles, I now have those same little divots in there. And I can use it round because it does not matter at all that these poles twist in their spot. I'm gluing them in place. If they twist, who cares? Now, if you have to try to keep alignment, yeah, maybe use a square notch on top of that or something like that. Or just try to be really careful. Ultimately, these are just some super simple ways you can plan for an object that does need to be, that you want to print, that does need to be assembled, but you can consider how it's going to be assembled afterwards. Ultimately, what we're trying to do, you keep separate parts broken up and so they can be printed more simply. Um, and then you want to be able to put them back together. Well, just put a couple little notches in there somewhere so that it's not just an immediate full slice apart, but it actually has little tabs, little notches, little registration keys is what they're called, that help keep the thing aligned while the glue sets. So hopefully that gives you some good ideas of how you can model something to compensate for being broken apart. Otherwise, Some of you are just going to be taking some parts literally apart and printing them flat. That's perfectly fine. We just talked about a few that have some doors, things like that. The quick last one I wanted to note is that um, I will say that actually I'll just instead of starting a new one, I'll just nope, don't save, I don't care. There we go. I wanted to address threads real quick, just because it was asked. How do I thread something together, or are threads a problem? Yes and no. And what I mean by that is not trying to be intentionally vague, but let's just start a cylinder on top. Cool. I'll just make it a little bit larger and we'll go upwards a little bit. Neato burrito, new body, lid, hide that thing because I want to make a cylinder on the bottom. And I don't know, sure, 20. And drag that down a little bit. Whatever. Okay. So let's say, again, we'll use that to cut target body, top, cut, cut. Yep, great. The reason I did that, I want to show you like with threads. Yeah, you could have used the whole tool, but using these, it's more precise. So let's just install a thread on this. Measure over, sure. A default apparently has 20 at a 2.5. I want to model it because I want to see what I've got going. That'll save. Repeat the thread on there. Same deal, super duper, great. So the issue is not in spacing even. You can see that fortunately this looks like it's actually lined up and it does actually compensate a bit. It gives me just a teeny bit of spacing. The issue I run into is the top and bottom of the thread. As you can see, let me hide the body there, is you end up with these weird little, it's this weird little extra bit, nope, of the threading. And you can see how it's not going to line up properly. How I try to compensate for this is before I thread, I try to put a little chamfer on there. And let's say, I don't know, 5. That might be a bit much. 2. Sure, that seems slightly more reasonable. So I put a chamfer before the threading. Now when I recalculate, the problem is it does chamfer, but now the thread doesn't go all the way to the top. So how do you compensate for that? Delete the chamfer. And honestly, the only ways I've really found to do anything about that to help for clearances is try to, because you can't chamfer like here, because that's just not a thing. It gives you some super weird results. Is basically I'm trying to like clean the edge up. I have found really the only real way to do something like this is like an unnecessarily complicated way around. And that would be to do a sweep around that. So how would I do that? Take here. So I'm just looking at it from whatever side, doesn't matter. Do a projection. And I'm just gonna like make a triangle from the side there. And what I'm gonna do is so now I can snap forward. I got my threads all there, great. And what I could do is sweep that triangle shape around the path that is the top here. Problem is I needed to have had, sorry, I should have had a second sketch, ugh, of this circle. So let me just copy that, project that line again. Just copy that. There we go. Because see, I was trying to copy a perfect circle around that. Now, when I snap forward and I have that thread there, now I can do a sweep of Ugh, God, trying to grab all the parts of that corner and sweep around the path of the circle that I made. Sure, make it a new body. And now I can use that as a cutting tool. Target, use that. Yep, cut. Don't necessarily need to keep the tools, but I can leave them there. So now I have an evenly chamfered top. It's a really unnecessarily complicated, overcomplicated way of working, but it does get me to where I need to be. Of now I have, of course, you're not really seeing it on the side here, a chamfer around that will just help that thread because threads just sometimes do weird things. The other solution can be, if you need a chamfer on that, we'll print it as it is, and then we'll literally use a file or something like that, or sandpaper to sand a little bit of a chamfer onto the physical object. So it could also be, don't discount the fact that everything doesn't necessarily have to be done as a mo in the modeling. If you need a little extra clearance here and there sometimes, well, the model works. You could do, if you could knock it out in the model, excellent. If you can't, well, at worst, we'll figure it out as a um physically printed model, and we'll just use sandpaper or something like that. So hopefully those things answer some questions, especially for or just how do you register things together, how do you keep things locked together, and how do you actually go about gluing them back together once you want to print these and build them out from there. So hopefully that helps. And yeah, we'll figure it out from there. So good luck, and hopefully don't go too crazy with it.